Today, we begin our data analysis for Apache NuttX RTOS to understand why we are consuming so much of GitHub Actions runners for our continuous integration. In today's video, I'll talk about how I dumped out everything from GitHub, from the PRs to all the jobs to their run durations. Just to recap, why are we doing all this? Well, over the past couple of months, we've seen pretty high utilization of our GitHub runners. If you look at this Apache NuttX issue down here, high utilization of GitHub runners, at the top of this issue, scroll down, you see a chart. Now, according to the policy stated by ASF infrastructure team, we are not supposed to exceed 25 full-time runners. And if we do that, if we consistently exceed 25 full-time runners, we will affect other Apache NuttX projects and deprive them of their GitHub runners. And as for ourselves, we will lose our access to GitHub Actions. ASF infrastructure team will remove our access to GitHub Actions if we ever exceed 24, if we consistently exceed 25 full-time runners. That's why we need to make sure that we stay below the limit. And every day we use our own metric to measure that. However, over the past couple of months, we see a disturbing pattern where there is this spike in usage of GitHub runners. Something happened around 9 December. Since then, well, just to show you how to read this chart, we have a this is our limit, 25 GitHub runners, right? So we have a vertical axis here that says how many GitHub runners we are using, and on the horizontal axis we have the date. Now, if you notice that on 9 December onwards, the pattern seems to have changed. Yes, we have smaller spikes every 3 months or so due to NuttX release. Average out, it's still below 25. But our usage became quite high over the past couple of months since 9 December. There is a peak here for NuttX release, which is unusually high compared to the other NuttX releases. Then after that, we have a peak period here in January and February of 2026, followed by a dip just before the Lunar New Year holiday. And after New Year holiday, we experience a slight peak, and we are back to normal. So what exactly is happening here? We have some clues. We think it is due to a lot of PRs being submitted by our developers before they went for the Lunar New Year holiday. But we never had a chance to count through the data and figure out how many PRs were actually submitted during this period. And it's not a fault of our developers for submitting PRs, but is there something wrong with the way that we are building these PRs? Which PR had the longest build time? Why were they slow? Is it because the build fails and our developers had to resubmit them many times, causing a lot of excessive rebuilds, therefore using up our GitHub runners? And also, we have two repositories for our PRs. We have NuttX repo, we have the NuttX apps repo. What is the distribution like? Are most of the GitHub runners being used by the NuttX repo or the NuttX apps repo? Right. So it was unfortunate that we didn't have a time to do this data analysis during January or February 2026, but I worry that this might happen again. That's why today I'm going into GitHub to extract all data to do more analysis so that we figure out once and for all what really happened during this peak period here, so that we can prevent this from happening again. And it might mean that we need to do some kind of fixes to our CI process to make it work better. Right? So yeah, in our previous video, we talked about these points here. We talk about things that might help reduce our usage of GitHub Runners. So like I mentioned earlier, we have a suspicion that we are handling too many PRs, but then the question comes: what is the limit? How many PRs are we allowed to handle in our system before it exceeds the limit and it goes haywire on the GitHub Runner usage? Well, we also need to understand why exactly are our developers canceling their jobs, submitting new commits, and rebuilding their PRs. Is there a reason why this is happening? Hopefully the data will tell us. We also have questions like, what if we, instead of waiting for the job to terminate all the way to the end, what if we just terminate it halfway when they fail? So would that save GitHub runners, or would that cause our developers to trigger more builds, which will eventually use up more GitHub runners? Lots of questions. That's why we are going to dump out the data and do our own detailed analysis. Today, I will be talking about this repo that I created. It's called NuttX GitHub Jobs. It's really a complete dump. For the past 3 months, hopefully we'll extend for a whole year, of all the pull requests, all the jobs, and all the run durations for both the NuttX repo as well as the NuttX apps repo. Let me explain what's happening in here, and towards the end of the video, I'll talk about how we run this script to dump out all this data from GitHub, and how we plan to do analysis of this data that have been dumped out. We are also having some initiatives where we're doing smarter ways to build our CI systems. So, for example, if we find out that there are certain dependencies in our CI, jobs, and some things are not really affected by a PR, we try intelligently not to build those things that are not affected by PR. But that also means that we need to make sure that our dependency analysis is correct. That's why it may be helpful to look through the PRs that we dumped for the past 3 months to see how our dependency analysis will work for all these PRs. Let's go into the PR folder. The PR folder simply contains all the JSON dump of the PRs from GitHub. We have a whole bunch of JSON here. We will see 2 types of JSON dumps. We have the 5-digit ones, and we have the 4-digit ones. Okay, they are somewhere in here. The list is too long. The 4-digit ones belong to NuttX apps repo. The 4-digit PRs belong to the NuttX apps repo, but the 5-digit ones come from the NuttX repo. So we are looking here at the dump. This is directly from GitHub API. We remove some of the complicated stuff, non-essential stuff, like the comments and so on. Right? The actual PR description, the whole bulk of it, we leave it out because it's not really useful for analysis. We see who created the PR. We see the files. So there are multiple files being changed. It will tell you what path of the files to change, how many lines were added, how many lines were deleted. Normally, we will see multiple files in there. Right? Let me show you a bigger example. So I have another example here. It's more complex, right? Yes, we see the author here. We see that a whole list of files here, right? Each file has got tells you 2 lines were deleted. 2 lines were added, 0 lines were deleted, and so on. Next, we see where this PR is coming from the external repo. This is also useful information. Labels. As part of our build process, let's head on to this chart here. Our build process uses labeling to speed up the CI builds. You see here that when a PR is submitted, we have a labeling process that identifies the architecture of the PR, whether it's for ARM32, ARM64, RISC-V, and so on. So later on, we have a select build stage, which will look at this label here, the architecture label, to figure out should we be building ARM32, ARM64, RISC-V, and so on. If this architecture is only for ARM32, then we will build only the ARM32 targets. We will not build the rest. So this speeds up our builds. We call this a simple PR or simple build because we're only targeting one architecture. If this particular PR spans across architectures, or maybe it's for some OS components and drivers, we will do a complex build, which means that we will do every architecture here. Our goal is to target simple builds, simplify the build as much as possible, make sure that we only build the targets that we need. Heading back to our PR, we see, so we see the status. So we see that this is a merge. Most importantly, we see the title and we see the URL in case you need to find out more information. This is pretty useful information stuff. If we're doing some kind of a historical analysis of our PRs for the past 3 months, we have data captured for the past 3 months. Hopefully, I can go back and extract more data up to the past year. And all this is available here in this repo, and it's full text searchable. Now, we talked about our problem with our high utilization. How do we want to fix this? Obviously, we want to backtrack and look at all the GitHub jobs that were executed and how much time they took. To do that, we look into the job folder. Right. So we have lots of data in here. Let me just click into one of them to show you what's the JSON file like. So this tells us that this is a build job. A build job that failed, right? We might need to do more analysis to find out why it failed. And here is a PR. It doesn't mention the PR number, but then it has a title. So we will probably use this to match against the PR. Instead of going through the proper way of doing it, getting lots more information from GitHub, let's do the simple way for now and match it by title. We match the job with the PR title. It's not going to be 100% accurate, but might be good enough for our analysis right now. This tells us the elapsed time. It tells us what time it started, what time it ended. But the way we build jobs in NuttX is that we are highly parallel. We start off, under ARM32, we have a few jobs, ARM01, 02, up to 14. We fire off these jobs in parallel, not just ARM, but also ARM64, RISC-V, and so on. So getting the elapsed time for this entire build might not be sufficient. For a complex PR, complex build, we are looking at 3.5 hours of elapsed time to build a PR. But because of the parallel nature of our build, we actually have to go into the job and look at every single job here, how much time they add up. Okay, and obviously it will go beyond 3.5 hours. We've seen past data where the jobs will add up to even 29 hours. And that's the time that we're being charged. Number of GitHub runners that we are being charged is based on that total elapsed time, the 29 hours that we use. essentially that means that we are consuming 29 hours of GitHub resources, and we are charged for that, right? So our goal is to keep that total number low. It doesn't have that total time, the total runtime here, but to check that, we have a database ID. This database ID, we can use it to match against the duration folder. In the duration folder, we have everything indexed by the database ID. The database ID, actually in our own terms, is we call it the run ID of the job. GitHub calls it the run ID for this particular GitHub job. If we look up this number here in our duration folder, we will see this 1786000, which means that the total amount of time consumed by our build job under GitHub Actions is 1,786 seconds. This is milliseconds. So that's the time was consumed. It doesn't seem very long, but then again, this job failed. We're not sure why it failed. We have to look up and find out. How do we correlate this and map this back to the PR? We have the title here. The title says, use kconfig to control sequence number to save memory. We have to match this back to the PR. We see that the PR is this, use kconfig to control sequence number to save memory. There, and we have all details here. And once we link up multiple build jobs to the same PR, we can understand the history to understand, to know how many times this failed, how many times this PR was resubmitted, recommitted, and how many times this PR was rebuilt. And out of all those rebuilds, in total, how much GitHub Runners do we use for this particular PR? And then later we understand, what's the cost behind this? Why did it fail? Why was it resubmitted? Was it failed due to some code errors? Was it failed due to some other process in the CI that killed this build? We need to understand what's going on, right? Right. That was a quick run through of the data that we have in here. Let's go into a quick discussion about how we dumped up all this data. We have a script here called dump GitHub jobs.sh. If you go in there, we can see that this is how we dump the PRs from our repo. We use the the GitHub command line tool to dump out all the repos by date. To dump out all the PRs for that repo by date. And when we get the result, we look through each one, we dump it into the file, right? The PR looks like this, in JSON format. Next, we have the dumping of the GitHub jobs. Again, the GitHub command line tool helpfully provides us a tool to dump out all the jobs on a given day. We dump it up day by day, and we extract them into the individual JSON files. And it looks like this. We saw this earlier on. Finally, we have the GitHub job duration. Now, there isn't a command line tool for that. We have to use curl to call the GitHub API to fetch the timing and extract the run duration in milliseconds. This is the number that we dump into the file, and we need to match up. And we do this for all the days. Ideally, we would like to backtrack up to 365 past days, but realistically, we'll do it in chunks. We will compute the date, and we will just simply dump the PRs and jobs for NuttX and the PRs and jobs for NuttX apps. We don't see the dumping of durations here because the dumping of duration is done inside here, right? So as we dump the job list, we will also go into the duration and dump it here. How do we run this? If we go into VS Code, just check out the code, and then just run the script. Just make sure that you have a GitHub token in this file here. It doesn't require privileged access. Any GitHub token that has got read access to public repos will do. Just run / dump GitHub jobs as such. Yep, and we are going through the list of days, and we are dumping out the PRs. There you go. We see the PRs, we see the jobs, and we see the duration. And this takes a while because if we run this, we put like delays in there. You see that every time we make a curl call, we sleep 1 second. Every time we handle 1 day of data, we sleep 1 second. Because GitHub will apply rate limits. We will get blocked if we call GitHub API too many times. That's why all the sleeping is happening here. And you can see all the files here. And once we have the files here, I'll just simply check them into the repo, update dump. And this goes straight into our repo. And it still goes on. Right, let me stop this for now. Maybe now let's check about how we do the analysis. Yes, so we have the 3 databases. We have, let me just pull up a sheet of paper. Here. Right. What I've just explained is that we have 2 repos, right? We have the NuttX repo, and we have our NuttX apps repo. We created our own script that will call the GitHub API to fetch all the data from these 2 repos, and we export everything. The things that we export, we have our PRs, we have our jobs. These are the jobs that will run in GitHub Actions. And from each job, we have a run duration. So what's next? We want to use this data to find out why exactly are we taking so much, doing too much usage of GitHub Actions. Is there something wrong with our CI process? Well, the way we do this analysis is that we will dump out the data from these databases, and we will do a match. PRs and jobs, well, we see that we can match them by title. It's not a perfect match. There is probably a better way to do this, but we will use this for now because we don't want to dump out too much data from GitHub API. Okay, just complete this. Script does this, and script does that. And jobs and duration, the thing that matches these 2 is the run ID. So it becomes like a relational kind of database, except it's in JSON format. Now, analyzing a JSON database gets quite tricky for doing performance monitoring. Therefore, what we'll do is that we will do our analysis in Google Sheets, a Google spreadsheet. Google spreadsheet will not be able to handle JSON that well, right? There are tools, yes, for importing JSON, but it's kind of messy. What I propose to do is that we will flatten it. We will take all this data here, and we will just flatten all this into a TSV file, a tab separated file. Why not CSV? CSV uses comma. There's a chance that our PR titles have commas in there, so it's kind of risky. So what we'll do is that we will just export all the data into TSV format. But our PR data can be quite complex. It has nested fields and all that. So we need to remove the nesting. In our PR, if you look at this thing here, right? See, this is nested. If we want to export this into a TSV, no, not so easy. So we just skip this part. It's not so important. But what's important are the labels. We need to understand that this particular PR was labeled as a change to the file system. So it's an always level change. Also, it impacts memory management. These labels don't really look very helpful right now, but we're interested in other interesting labels like the architecture is ARM32, architecture is RISC-V, and so on. We want to identify specific types of labels, and we need to investigate if this particular label says that it's supposed to be a simple build, let's say ARM32. Why is it taking so long to complete? Therefore, these labels we will flatten it. Our labels will probably go into a okay, right. So we have a TSV, right? We have it's going to be one huge row. We'll have one record per job. So this will include the PR information, which includes the label. Label will say things like arc, let's see, 32. It could have a few. It could have a few things in there. So it could be also arc 64, for example. So we might end up compressing the nested.json into a comma delimited field. Yeah, so it makes analysis a bit more tricky, but at least we capture some of the useful information, right? So with the PR data, we have the including the labels. We will have the job information also, and of course we will have the duration. So remember that we will match the PR to job by title. We will match the job to duration by the run ID. And this TSP gets imported into Google Sheets, and then we can do analysis. We can do a pivot table to understand sum of all the durations by PR to find out what is the PR with the most total duration. So then we can find out which particular PRs are taking the most time to execute in GitHub Actions. We can also look at interesting data from the job status, whether it was completed, whether it was successful, just to understand why, whether there's any difference between cancelled jobs and completed jobs, and how much time they take in NuttX CI. And also, are we wasting any resources on cancelled jobs? The labels will also be interesting. We want to find out what kind of jobs occupy the most time in our NuttX CI. Yeah, so this is what I plan to do in the coming weeks. Hopefully, once we have all this data, we will answer these pressing questions. What happened during the past 3 months? Why did it spike up? Is it purely because we are handling too many PRs? Or maybe is there a problem with our build system? Are some builds taking a lot longer that they should? Or is there a reason why our developers are resubmitting PRs, triggering too many recompiles, right? Yeah. So this is what we hope to achieve with this setup here, and I'll make a new video and update you of my findings when I've done the research. Thank you so much.